should consist of 4 ordered pairs. Okay, graph each equation. So now we're going to graph. Remember that this is rise over run, and it's going to look like this. Now you know all rational numbers are over 1. Okay, so this is over 1. And as I mentioned, this is rise over run. Okay, and first we count the rise. So we see that in the rise we're moving -2, but we're moving 1, +1. So we start at the origin, and we count -2 up and down. Rise is up and down, and run is horizontally, right? So we're going to count -2 down. 1, 2. And the run is 1, it's +1. So I'm here, so I'm going to run +1. And then another 2. 1, 2, 1. You could go the other way, where you totally invert this operation, where we would invert it. As you see it here, we have -2 over 1, rise over run, but we could write it as +2 over -1. Instead of moving down, as we were doing here, -2, run 1, -2 over 1, now we're going to move +2, rise first, and then run. So our rise will be +2, and our run will be a -1. Rise will be +2, and our rise will be -1, and our run. So all our points are actually these points. As you can see them, those are our points on the graph. And then we connect them with the line, and we write our equation of the line. Okay. Now we have the Y-intercept slope, okay, where we only have an x with no coefficient, so our x is 1. It's just 1 over 1, right? 1 over 1. And our y-intercept is 5. That means we're going to start at 5 and then count 1 over 1, like this. So as mentioned before, this x is over 1. And that's our slope. This is our slope. This is what we're going to do for rise and run. But we have a y-intercept, and the y-intercept is where we actually start. So we would count from the origin 1, 2, 3, 4, 5. So this is actually where we're starting our count. We're not starting from the origin. We're not starting 1 over 1. We're not going 1 over 1. 1, run 1. 1 over 1. No, we're not doing that. We're actually starting at the 5, our y-intercept. So we have to count 5, and then from the 5, we count rise over run. Rise 1, run 1. Rise 1, run 1. So those are our first 2 coordinates. Okay, right there. And remember that we can also do it invertedly, where now we're going to have -x and -1, where we've just changed the symbols to both of them so we can move in the other direction. So if that's the case, now I'm rising. My rise is -1 and my run is -1. -1, -1. You see? So now my new points are building this way, infinitely. And they go both ways infinitely. So then we draw our line connecting all the dots, and we write our equation. Y plus x equals, y equals x plus 5. And this is what the slope of the line would look like. Make sure that you copy these down. Okay? Make sure that you draw both your graphs for 7 and 8. Question 9. Each small smoothie x costs, okay, each small smoothie x costs $1.50. So this is our small. Okay? We don't know how many smalls we have. Costs $1.50. And each large smoothie y costs $3. So double the price. Find 2 solutions of a small smoothie 1.5x plus 3y, okay, plus the a large smoothie, the price of the large, equals $12. To determine how many of each type of smoothie Lisa can buy with $12. So how many of these can she buy, and how many of these can she buy? Okay, let's say if she were to buy 2 of these, it's $3, and if she buys 2 of these is $6, and that's $9 altogether. So she still has room to buy more. Okay? So how can we solve for this? Let's choose different values for x. Okay, let's choose different values for x. Let's make x2, or let's make x4. Okay? So your equation would look like this. Okay? And what we could do is we solve. So 1.5 times 4 equals 6, right? Is equals 6 plus 3y equals 12. Subtract the 6 from both sides. Okay, so now we have now we have 6 on this side, and equals 3y. Okay, and then we can divide the 3 to isolate the y. And when we do so, we get 2 on this side and y. So this coordinate would mean x is 4, and your domain is 4, and your range is 2. So what does this mean, this one? It means that she could buy 4 small smoothies and 2 large smoothies, and this would equal $12. Okay, so that's one solution. Each small smoothie costs, what are we supposed to look for? Find 2 solutions. So I found one for you. You find the other, okay? You find the other. Choose another value for x, okay? And solve for y and see if it'll give you another coordinate pair. Okay, you solve the second pair, I solve the first one. Lesson 9-3. Constant rate of change and slope. For more information, please refer to pages 393 to 402, 396 to 402. Okay, let's look at the example. So now we're looking for constant rate of change. Find the constant rate of change in the water level. So we have the time, and again, this is our domain. Okay, and the water level, so this is our independent, and our water level is our range, which is our dependent. This one depends on this one. We chose the times. The times are chosen. We want to look at the time at 0 minutes, and then at 4 minutes, and at 8 minutes. And the water level changes depending on the amount of time that we looked at it. If we looked at it after 1 minute, it wouldn't be this. Okay? That's what makes this the dependent variable on this one. Okay, so we see that at 0 minutes, it was already 5 feet of water. At 4 minutes, we lost 1 foot of water. At double the amount of time, at 8 minutes, we lost another foot. I'm seeing that we're losing 1 foot of water every 4 minutes. Do you see that? We're going to look for the rate of change, as we've done in the past, where we compare one value to the other, and then we take the original value. So for example, we see that the change in water level has gone from 5 to 4. 5 to 4. So here we have change in water level. 5 minus 4 is 1. And in the bottom, we have the change in time. 0 minutes to 4 minutes. It's in negative 4 minutes, you could say. Okay? So now we have 1 over 4. And this negative can apply to the entire fraction. So 1/4. 1 foot lost in 4 minutes. Or negative 1/4 feet per minute. Okay? And that's actually what we're losing, okay? We're losing 1/4 of a foot per minute. If we're losing 1 foot every 4 minutes, that means we're losing 1/4 of a foot every minute. The rate of change is negative 1/4 feet per minute. Or if we wanted to write it as 4 feet, 1 foot every 4 minutes. That works too. Okay, you have questions 10, 11, 12, and 13 to do as an independent practice. Find the constant rate of change between the quantities in the table below. So we're looking for the rate of change. X and Y are right there. They both start at 0, so at 0 time, there's 0 money earned. After 4 hours, we earned $31, so it looks like it's still slightly less than $8, right? Because if we were to divide it, so I'm gonna say it's about $7.75 maybe. And then here again, double the amount of time, we made $62. 62. Okay, so I see that 4 is 31. If we can simplify that to the rate of 1, that'll tell you your rate of change. If you can simplify 4 over 31, okay, that'll tell you how much we're earning per hour, and that's your rate of change. Okay, so go ahead and solve that, and then find the slope of the line that passes through each pair of coordinates. So we're going to find the slope of the line. These are the coordinates, boys and girls. Now we're working backwards. This is our x and y, our x and y. In order to find our slope, we're going to use this formula here. Okay, m means slope. Okay, m is slope. And we're going to look for the change in y, okay, from this y to this y, or this y to this y, and the change in x from this x to this x. Okay, so if we replace our variables, we're going to call this is our y2s. Okay, these are our 2's, and over here is our 1's. Okay, on this side is our 1. So this is our y2 right there. This is our y1. This is our x2 and our x1. And now we're going to replace them. Okay, we're going to replace these by saying m is y2 is 4 minus y1. On the bottom we have x2 is 6 minus 0. Okay, what is that? That is 3 over 6, which equals a half. And this is our slope. M equals a half. Okay? They're asking you to find the slope of the line. The slope of the line is m equals a half. Okay? Rise over run. So you would go up 1 and over 2. And you could graph this. Up 1 and over 2, right? Up 1, if you had to graph it, and over 2. So just the same way I did this one, please go ahead and do number 12 by using this formula to find the change in both, and then finding the slope. Question 13. A lizard is crawling up a hill that rises 5 feet for every horizontal change of 30 feet. Find the slope. So they're telling us that we're going up 5 feet, which is our rise, right? Over 30 feet. For every 30 feet, that is our run, right? We move horizontally. Pay attention to this. We move horizontally 30 feet, right? That's our run. And we move vertically, crawling up a hill, vertically, 5 feet. There it is. This is our rise. This is how much we're going up the hill. And this is our run. This is the distance we're running horizontally. Simplify that. If we simplify it, we have 1 over 6, don't we? So for every one little square that we go, we're going to run 6. And every one, we run 6. There's our slope, 1/6. Okay, boys and girls, that's all for today.